everyone. I am Marcus. I come from the University of Melbourne and also from the CSE of Spatial Information. And my background is in biology and computer science, so my service of support for this tool in environmental visualization is my way to unify those two backgrounds. What I'm going to do is give an introduction that we have a common ground in our vocabulary, and then I will describe my framework architecture, and then understand it with a workflow example, and then give us a big summary and conclusions. So, what I basically want to do is take advantage of current e-science platforms that are now involved in fashion, and they allow shared resources and collaboration between many stakeholders, especially scientists from all over the world, so that we don't have to every 2-3 years come together in a conference to share our thoughts, but we can do it every time we want. And to do this, I want to use not recreate a wheel, reinvent a wheel, but stay to the shoulders of giants. Not only my colleagues, but also the already proven in the industry technologies that allow me to do just this. Particularly the grid of cloud computing, and you all know all the Google, for example, the Google or Amazon technologies use this cloud computing, and so that it would be my shoulder to be sharing and to enhance performance, and then in order to collaborate in an environmental model output, especially as you have seen, we have seen so many models and so many particular solutions to particular examples, but most often than not, we want to share some resources or take advantage of what our colleague or me, myself, have done before to solve another similar but not quite the same problem, and then we face a lot of challenges. To do this, we can have some high-level architecture framework, which is standard by EEE, and it's just a way to communicate between models, so that the same way as we use English to communicate between us, they use HLA for the models to communicate between themselves. To glue all these, we use the service-oriented architecture, again, another framework that allows just this. In a modular fashion, I just, using standard protocols, I can get all these particular tools or models to interact between themselves. Why? The basic idea is that we always need a particular software to solve particular parts of our challenges, of our questions, and then we have to code with Microsoft Word and then SVI ArchiMap, and then it's better with the 3D Max, but how can I import what I did before with the other two, and especially to make deadlines or whatever. So I need to stress the fact that we have to not use one particular suite, nor be completely open-minded, but take the best tool for the best part of my question and use it efficiently. To do this, and I will try to follow the KISS framework, keep it simple, but not simple. You just understand the layer architecture of this solution, and I'm going to explain each and every one of them. The first part will be to orchestrate or articulate all of this in a way that we actually solve the particular problem. And if I have this visualization layer and this management application layer and this data value services, you will understand later on how I can not only solve my particular problem in visualization, but we use this strategy or solution to cope with any other question or challenge that you may have in chemistry or in physics or in mathematics, and you name it. The first part, I want you have been loyal to us in this session today. You will remember our presentation of this morning. My colleague Jean-Philippe showed the potential of Google Earth or VNS, Visual Nature Studio, where that software that creates high definition rendering and can really tell the story of how the impact of certain challenges of certain climate changes can do it with one image, and like following the program, one image worth more than 1,000 words sometimes. And also using the game engine, it can be SIF, the one Dr. Bishop presented this morning, or the one we just saw from Build Tools, and use the best one. For instance, we have evaluated Build Tools, and it's very good, but it's very expensive. So if your organization doesn't have enough money to do that, well, you can switch to Google Earth, which is cheaper, and then solve the kind of problem that you want to solve. Completely separated from this is what I really want to solve. So in this case, I want to understand the workflow of some scientists or experts that wants to understand certain landscape scenario, and then I understand how the process is, and then I can be with that process throughout all its cycles and understand them and provide the tools better suited for that particular time. If we are, for instance, trying to render an image in high definition render, I can remember that the session, the experts want to give this in high definition, but this takes time, and this may take a while. While we keep discussing, while the scientists keep discussing, I can give this request to a certain manager, and they will perform this high definition render, and while the other people can keep talking and having their discussion. On the other hand, I can ask for a climate change model, or a crop growing model, or a landscape usability or sustainability model. And again, we all know that all these models take some time. They are implemented in different languages, .NET, Java, whatever. Again, this orchestration service abstract that technology and abstract this particular tool from our discussion that we are having in a way that doesn't interfere, but rather supports when it has to be. And last but not least, this workflow manager, when it's suitable, it can use good middleware, which is actually available and for free. You just have to create a Google account or MSN account, and you can have this high definition render or models that are number crushing, very demanding on desktop resources. You can have them there and use the tools that our current technology gives us. Then, aside from what I have told you, but the first presentation this morning quite suggested, we are dependent of the data, what we're going to show, and the 3D object library. It's also a work in progress that exactly will get fostered by this and recycled by this process, and I can get the particular objects I want, but again, most often than not, other particular data like the results of other environmental models, whatever, they lie in different servers, or even the current weather, it's a live feed. It's a live feed that again is freely available for many videos. So if I have this abstract in this layer, it will again be queried upon whenever I want and wherever I want in a timely fashion. And how can I glue together all these different technologies, all these different services? Well, we have to rely on a common ground, a common